When we talk about linear regression, there's a few vocabulary words that are important to know. The first of which is the line of best fit, which we also call the regression line. So let's say you have a set of data and you can plot those data points on a graph and it comes out looking something like this. Now when you look at the points here, you can tell that they don't have a linear relationship. If you were to compare the line that connects 2 points and find the slope of that line, then compare the slope of a line between 2 other points, those slopes would vary. So we need to draw a line that fits this data in order to approximate values. So one possible line of best fit or regression line would look something like this. So when you draw a regression line, you want the number of points above the line to be about the same as the number of points below the line. And then using this line, we can find the slope of it and create an equation, and from that equation, we can approximate values. So the second vocabulary word that's important to know is interpolation. When you interpolate data, you are looking at the given data set and you're approximating values within that set. Now for extrapolation, when you extrapolate data, you're taking a look at your given data set and you're making predictions for values that extend beyond that given set. So let's use this information and try an example. Here we have a problem that talks about life expectancy. So we're given a set of data that says that in 1950 you could have expected to live 68.2 years. And as the years progress, so does the life expectancy, all the way up to the year 2000 where you could have expected to live 77 years. So we're going to use this information and plot it on a graph first. And our x values for our coordinates on this graph are going to be the number of years since 1950. So for this first point, 1950 and 68.2, our x value is going to be 0. So there's our first point. Our second point for 1960, our x value is 10. So we plot 10, 69.7. For the 1970 life expectancy, we plot it at 20, 70.8. For 1980, we plot the 73.7 at 30, 73.7. For the 1990 value of 75.4, we plot that at 40 and 75.4. And our last point for the year 2000, that's 50 years since 1950, so we plot this at 50 and 77. So now looking at these points that we've plotted, you can see that they don't quite have a linear relationship. So we need to draw a regression line. So one possible line would look like this. So as you can see, we tried to get a line that was the best fit for this set of data. Now using this line, we can find its slope and then find its equation in order to estimate some values. So looking at this line here, let's choose 2 points in order to find the slope. And we're going to use the points, this first point here, which is at 0 and 68.2. And then let's use the last point at 50, 77. So our formula in order to find the slope m is y2 minus y1, and that's over x2 minus x1. So we just plug in our y and x values from the 2 chosen points into this formula to find our slope. So our y2 value is 77, and then we subtract our y1 value, which is 68.2. We put that over our x2 value, which is 50, and we subtract our x1 value, which is 0. Now when you simplify this expression here, you're going to get a value that's approximately 0.18. And then there's our slope m. So we can plug this value then into our formula, our point-slope form of the equation, that will represent the equation for our regression line. So our point-slope formula is y minus y1, which is equal to m, the slope, times x minus x1. So we have our value for m. We have values for our x1 and y1, so let's plug that in, and then we'll solve for y to get it into our standard form, and we'll have our equation. So y minus y1, we're going to use our first point here, 68.2 is our y value for that point. That's equal to m, which is 0.18, times x minus our x1 value, which is 0. And then if you were to simplify this equation and solve for y, you'd get y is equal to 0.18x plus 68.2. So this is our equation that represents our line of best fit for this set of data. So now let's use this equation and we'll approximate some values. Okay, so suppose you are asked to interpolate the life expectancy in 1987. So we use the equation that we just found, y equals 0.18x plus 68.2. We find a value for x, plug that in, and we'll have our life expectancy. So the year 1987, that's 37 years since 1950, so that becomes our x value. So if we plug that in, y is equal to 0.18 times 37 plus 68.2. We do this math here, and we get 74.86 years. So that's the life expectancy in the year 1987, which if you look at our original data, that matches, because 1980, the life expectancy was 73.7, whereas in 1990, the life expectancy was 75.4. With the year 1987 falling in between those two values, so does our life expectancy. So let's go to a second problem, and we're going to extrapolate a value by extending what we know. Based on our equation here that we found, we're going to find the life expectancy in 2010, which is a year beyond our given data set. So in 2010, that's 60 years after 1950. So our x value becomes 60. Y is equal to 0.18. We plug in 60 for our x value, plus 68.2. So here's our equation for our regression line, and our x value of 60, because that represents the year 2010, 60 years since 1950. We do this math, and we get 79 years. So in 2010, you were expected to live 79 years.